First off, I might point out that in the note, we're told that this is not the actual graph. This is sort of a sampling. So let's take a look at what the actual graph would be. First off, the y equals x over 2 is indeed the blue graph that we have here. So that one is accurate. The other graph, the green graph, is supposed to be y equals 3 minus 9x. So this equation is supposed to be 3 minus 9x. So it does indeed have a y-intercept of 3, just like this one, but the slope is negative 9, whereas this slope is negative 1. So the green graph is going to be a lot skinnier than the one that's actually shown there. I won't draw that in, I'll just use that. However, this point also is not accurate. So let's see what that point actually is. So the other boundary is x equals 0, which happens to be the y-axis. So we need the area of this shaded region. So that's what our integral is going to be about. So back to finding the point of intersection. We need to take the negative 9x plus 3 and the x over 2 and set them equal to each other and then solve for x. So if we multiply through by 2, this would be 18x and 6. If we add the x to both sides, we get 19x equals 6, or x equals 6/19. Now ours didn't come out quite as cute as theirs. And then, of course, we can find the y value by plugging that into either one of these equations. For example, the x over 2 would get 6/19 over 2, which is 6/19 times 1/2, which comes out to be a 3/19. So our point is not quite as cute as theirs. And so now what we need to do is to set up the proper double integral to find that mass. So notice that this is a nice type 1 region, y simple, I call it. And so we can set up our double integral that starts with a dy. So the y's are going to need to go from this blue line, which is y equals x over 2, to this green line, which is y equals 3 minus 9x. And then the x's are going to go from 0 to 6/19. And the integrand is the density function. And of course, once we get that far, if we have a TI-89, we can then type that into our TI-89. Now, even though we can get the exact value on our TI-89, we'll go ahead and round this off because that's what the instructions want. And I'll use 4 decimal places for now. That way in the end, when we round to 2, we will not be off. So there is the mass. Now that's what we would put in our answer. To 2 decimal places, that'd be a 4.94. So then we'll do these in order. The moment, that's capital M, about the x-axis. Now that's going to be the exact same integral However, the moment about the x-axis, we need the distance from the x-axis, which would be y. So again, we can just take out our TI-89, insert a y in that spot, and we have that moment. Which we'll go ahead and round. Then to find the moment about the y-axis, same integral. As the mass, that is. But with the distance from the y-axis, which would be x. And we already have all of our calculations, our integrals that is. Remember, the center of mass in the x direction needs the distance in the x direction, which is the moment about the y-axis. And likewise, the center of mass in the y direction needs to be the distance in the y direction, which we'll go ahead and round to 2 decimal places.